I'm good. Can you hear me? Yep. It's good. Super. All right, everyone. Welcome to my session, Optimistic versus being an optimist in a pessimistic world. My name is Vincenzo Manano, and I've been developing solutions since FileMaker 2.1, certified in all versions since 7 to 18. 18, I got certified 2 weeks ago in Germany. It was very cool. Let's see, I work at Beeswax, and I'm director of FileMaker development at Beeswax, and work with a really talented and diverse team at Beeswax. Things that I love. I love research and development. I love data visualization. I work a lot with D3 and Tableau. I like going hiking. I like sharp knives, architecture, and I love parking backwards. This is a street in Germany. I have the philosophy that when you park backwards, you're always ready to go. Ready to go. And some of these people, I think, have the same mindset. Okay, what if you could dramatically reduce network traffic? Less network traffic translates into less work for the server, less network traffic on your network, obviously. Sending only changed values, to and from the server to the client. Reduce the number of locks the server needs to manage. That's another thing that you could save on. And then if you're using AWS, you could potentially save on data transfer because you're not sending as much data all the time. And what if you can significantly improve performance? So it enables things like the ability to audit changes, store data transactionally, faster rendering and responsiveness in your solution. So all that is possible, and we're gonna cover some case studies where we actually did this transition. So, how many of you know if FileMaker is optimistic or pessimistic record locking? How many think FileMaker is optimistic record locking? Raise your hand. Okay. How many say FileMaker is pessimistic record locking? Yes, it's the pessimistic side that wins this time. So FileMaker, and we'll cover that in a little bit. So this talk we're going to show the differences. We're going to talk about the differences of optimistic versus pessimistic. We're going to go on a little bit of a journey that we went on when we embarked upon doing things in an optimistic manner. So we'll talk about the journey. We'll talk about some tools that you can use to help you understand what's going on and understand if you've made performance difference altogether. We'll talk about some techniques that we've kind of worked on and evolved, and that's it. So as a FileMaker developer or a database developer, you're often, like at the very beginning, you're learning the basic rules of database design. You learn about normalization, you learn the rules of the things that you're supposed to do. But oftentimes, once you've learned those rules, just like a musician practices and practices, and then they break the rules. So it's about understanding when to break the rules and know how to break the rules. So that's important. FileMaker does pessimistic record locking. That's the basic way it works. So if you go into a file that's hosted and you click inside a field and you start typing, FileMaker locks that record so that nobody else can get to that record and make changes to it while you're editing it. So record lock is locked during the duration of the edit. The server keeps track of the locks so that if someone else lands on the same record and then tries to make changes to it, you get a notification that the record is locked by somebody. Edits happen only locally while you're editing the data, and then the whole record is transported up or down. So you don't have the choice of I just changed the date of this event. Once you commit the record, the whole record as a whole goes up to the server. And then if some user is on that record, then FileMaker server, once it has an opportunity and realizes that it will send up a refreshed copy of that record to that user. And there's this concept of record modification count. So every time you make a change to a record, that record modification count number gets updated. And we'll see that in some cases that can be useful, but in some cases that's not as useful as one would think. Optimistic record locking, it locks the record only for the duration of committing the data. Server doesn't have to do more work because once the record is open and committed, then it's a very minute time that it's doing the work. So it doesn't have to track the locks for a longer duration. So my feeling is that I don't think it has more work to do. Edits happen on the server rather than on a client. And then you can also have the opportunity to send only the changes to a record. So that's an interesting point. Instead of using record modification count, we like to use hashes. And so what we have is this concept of past, present, and future hash, and we'll talk about that later. Let's see, optimistic record locking, there's more. So calculations, if you use this approach, you can move calculations from an unstored nature to a stored state. So there's a lot of close attention you have to pay to when you do that, but there's an opportunity to do that. And by doing that, there's some significant performance benefits that one can gain from doing that. You can also log edits because at that very moment you've changed the value, and if it was successful, you can log those changes as audits. Local editing, we'll talk about that. That's a technique that we use, and it's kind of a cool technique so that it's like your own local cache of data, and so we'll see some benefits that we have there. And there's no additional traffic, so that's the other cool benefit. If you're editing in globals or you're editing in a local copy of the data, there's no traffic going on the network, so you're saving on the traffic on the network. So this all comes with a warning, and warning is that if you unhinge yourself from FileMaker's inherent behavior, then you hopefully know what you're doing, because you could mess things up pretty significantly. So I do warn you that like if you have a simple set of tables, let's say a project and tasks, the percent of the tasks completed that should have transactional integrity to make sure that if you update a task, that the percent of tasks on the project record is in fact the right number of percent value, because you're unhooking it from being an unstored calc that renders when it displays to something that is static and stored, and you want it to happen transactionally. So, but other kinds of joins might be like, hey, I have a year table that shows me how many projects I had in a year. Those could be kind of like, I would say, eventual transactionally correct. So it doesn't necessarily have to happen right then and there. And so you can evaluate whether or not it has to be transactionally accurate right then and there, or it can be updated later. And so we'll see some of that. So a lot of this is predicated on improving performance so that users don't have to wait. So implications are that it's not for everyone. So in our case, we are responsible for systems that are used worldwide by many different users in different regions, and we've had a lot of years of experience in building solutions in cases like that where originally they were always complaining about performance, always, and to the point where it's like, we just can't use this if it's going to be this slow. And then we really stepped up and started to explore what we can do to improve performance. So again, I warn that it's not for everyone, and depending on solution complexity, there's a lot of variables you have to take into consideration So solution complexity could be another factor that might warrant that, I might not want to do this approach. Types of updates, I talked about those, transactional integrity versus eventual integrity. And then this is an actual link to Todd Geist's blog or video about transactions. He's talked a lot about transactions in the past. So I welcome you, if you have never looked at it, to take a look at it and understand how that works. Okay, so the important thing is when you embark upon this and you want to make improvements in this way, that you test everything that you do. You test and you measure. So we have test out new ideas. You can establish a baseline for what the fastest it could be and see, if you're on a remote network or on a WAN, if that meets or is as close as possible to your baseline. So test and measure. And I make a shout out, I don't know if anybody's here from FileMaker, but we really need built-in native tools as developers, like profiling and things like that, so that we can know what we're doing is making an impact and not kind of patched together like a script that says this is how long this takes or whatever. But I urge FileMaker, Claris, to build in some tools to help us understand, profiling of a solution so that we can see as developers what's going on under the hood. That's a very important need for measurements, for errors, and all kinds of things. On the community, before the community was changed, there was this tool called Network Monitor. I have not been able to find it. How many of you have used this tool or know of this tool? It's on the FileMaker community, one person. So I asked Jimmy to maybe post a link to the community when it becomes available again. I have not been able to find it on the new community, but it was available in the prior community. But this is a tool that FileMaker put out, built by Jimmy Jones. Jeff Benjamin, sorry. And it's a way to monitor network traffic. And it's very simple to use, but the way you use it is basically you click the button, quit and clear cache, and then you find yourself in the state of just before the thing that you want to do, and then you can say start, and then run the test on what you're wanting to test. So I'm going to talk about our journey. And so we went from native editing to this concept of when we got popovers, we used globals, so we take the value out of the record and put it in globals, let you edit it, and then send it to the server. And then we evolved to this concept of local file editing. How many of you know what that is? Okay, that's a new term, and we'll cover that. And now lately, we're still experimenting with local file editing and submitting using the data API. So we'll talk about that. And we'll talk about this term called commit footprint and the 3 hashes. And then another interesting new term and method that we've evolved called something that's very familiar in the web community called ModelViewController, but we have a twist on that, so I'll show you that as well. So the commit footprint first. So what the commit footprint is when FileMaker came out with Perform Script on Server, we were really excited about the opportunities there, but we were really cautious because we didn't want to mess up the performance of anybody's experience. So we were very cautious going in. And one of the things that we wanted to do is make sure that everything that we call on server, we know how long it takes. Okay, what's the time it takes to perform that event on the server? So this is a method by which for us to also understand if we move away from unstored to stored, then we're using a trigger to do that. And so we wanted to also measure how long that commit for that record takes to do all the work it needs to evaluate all the calculations. So what it is, we'll talk about what it is, how to implement it, and how it's helpful. So the commit footprint it gives you an ability to measure when you take unstored calcs to stored. And so for example, a simple thing with the projects and the tasks, if I have an amount associated with each task, I might want to say, what's the total cost of all those tasks on that project? So what we do is we create a timestamp field in the table, in the project table called update. And when we touch that timestamp field, basically it just, the result of if is just nothing, is in quotes there, but we concatenate the sum of the tasks. So as soon as the timestamp field is updated, this causes like a trigger for that event to happen on that calculation that was prior used to be an unstored calc, but then got converted to a number field as an auto-enter value. And then what happens is the timestamp, when that timestamp value is updated, it triggers that event to happen. So then those values are stored. Now, if you don't know this already, if you have a table like project and you have this field on a list view, when you look at a list view of records of projects and this unstored calc is visible, what FileMaker is doing is saying, oh, I need all the related records for this project, all the task records for this project, all the task records for this project. It pulls all of them down so that it can evaluate the unstored value of that field. But if you move to a stored state, then you store that value. It's just a static number. And so when you look at the project list, it just doesn't need to do any extra work. It just renders all the fields that are on that layout for all the record data for all those records of projects, and then you're getting just static data coming down. So definitely big reduction in traffic. So what we do is we measure the time it takes from the beginning of this call by setting a timestamp. UTC milliseconds is just a custom function that is shown at the bottom there. Down here. So it's just get current timestamp UTC milliseconds. And then what we do is we can either perform it on server, perform the script locally, or we can perform it on server. So we just toggle one and the other, and we get our measurements. And then so we get the inner duration that comes back as a result from the call to the first script, and then we get the outer duration as the call, the bounding block of this. And this gives us a measurement to see how long does it take for this transaction to occur from this client if I run the script locally, or if I run the script on server. And so we'll see some measurements there. And so basically the call of the script that gets called, whether locally or on the server, basically just we send an ID, we go to a layout, we find some records, we then start the inner measurement, and then we just touch the timestamp field, and by touching that timestamp field, we have done the thing to open the record. And then the record is open, and we commit it right away, and then we measure the time it took from opening the record and making the data edit and committing the record. And that gives us the inner measurement. And then we return that as a result, as the exit script result. And then, so we looked at the benefits that this has. So if on a local area network, you perform the script, that's 0.078 seconds. Perform script on server is actually slower. And that's because there's overhead in calling the script on server and getting a result back, etc. So, but the inner measurement is actually definitely faster because there is a little bit of distance the record has to get transported from your client to the server. But when you run it on server, it's right there, and the commit happens a lot faster. Now let's move away from the local area network, and we move away about 25 miles away from the server, and then we'll see that, wow, it takes 1.134 seconds to do that whole operation, but on the server it's like a fraction of the time. And a big difference, a huge difference in the inner measurement. So the record is open in a state that where it's committing the data, it's got to go all the way to the server and then actually finish off the commit and commit the record. So there's a big time span there. So let's move a little bit further, 50 miles from Oakland, and we see similar results. Okay, so a lot faster, right? And then let's move away to 5,000 miles away across the pond, as they say, in London, from Oakland to London. And now it takes 3 seconds for the whole operation to complete if I run it from a client. But if I run it on server, it's 0.27 seconds. And then it takes 2 seconds, over 2 seconds, to commit the record from the client. I mean, this is a trivial example, but it illustrates the point really nicely that running the commit on a server is a lot faster. Okay, so I'll talk about that case study that we had. This is a solution that we worked on with this client for over a decade. And about 4 or 5 years ago, we took this solution and really rethought things very deeply. And we refactored a lot of things, and so we had a big reduction in code, and that's always a good feeling to get rid of stuff. So we took base tables from 46 to 33. We took tables down to a smaller amount. We reduced them as well, reduced the number of fields and scripts and layouts. But the big dramatic difference was we went to an optimistic record locking approach, and we reduced the number of unstored calcs from 103 to 9, okay? And the 9 remaining ones were things where it's like, that's okay. It's just going to ever be viewed in California, and no one's ever going to look at that layout and need to do that remotely, so we didn't bother with those remaining ones. So the benefits were, I mean, the totals here show that we had a 64% reduction in code. Same functionality of the system, okay? So it's always good to do this kind of spring cleaning, if you wish. When they were announcing and I heard all the rumors of things that were coming, I was going to think like, wow, I wonder if my talk is ever going to be even relevant at this point, you know? So, but you know, with all that's coming, you might want to take all this into consideration and say, I wonder that old solution that we have and all the stuff that's coming might be a good idea to rethink things into what is the new opportunities. And I like to encourage people to rebuild rather than to just patch what they have, just because I've often seen things where it's like you don't really get as much benefit from just patching things with new features rather than rethinking and implementing them from scratch. So that's just my personal preference. The benefits for this group were dramatic. So they went from opening a file used to take 33 seconds down to 5 seconds. So users in London or Japan or Australia saw an incredible difference in just opening the file. They went from creating a new project used to take them 19 seconds to 2 seconds. They went from viewing a project list, took them 10 seconds down to 2 seconds. Admin view was a dramatic thing because they had all these portals and had valleys in all the portals that were unstored, and that dramatically changed as well. So that was a big difference for that team. In preparing for this talk, I downloaded the event management file that's on FileMaker's website of examples that they have, and I kind of used that as my experiment. So, and this was my network speed, okay? And so we're from Orlando, we have our server in Oakland, and we're like 2,800 miles away. And what I did is I did this technique where I unhooked the unstored calcs and turned them into stored calcs. And then, so I have an outer unstored calc measurement and an inner one. And so this is before I made my changes. And so the measurements are, if I perform the script from here, it's half a second. If I perform it on server, it's 1/10 of that. And then if I do the inner measurement of like how long it takes me to commit the record from here versus if I commit the record on the server. So very interesting, the 0.002. And so then if I change those calcs, there was only 5 of them. If I change them to a stored state, right, where I have that update field and I update the field, now the measurement was, it went from 0.002 to 0.007. And what that means is it's understandable. So what that means is that now the record that the server has to do work on to commit that record has to do the extra work to commit all those unstored values at that time. And that's the extra work that we're seeing here by the 0.005 seconds of extra time the server needs to commit that record. So for us, this is a critical measurement to understand this concept of like, oh, I have this table, it's 100 unstored calcs, and if we move them to this stored method, how long is it going to take the server to commit that record? So that's a very important measurement that we like to look at. And if you look at that number, 0.007, in 1 second, you could actually, in theory, do 142 updates on that one record, versus like in the other case, you could hardly sneak in 2 updates remotely. Again, record modification count, that's not really useful to us. So what we do like to do is we like to build these hashes, and I'll talk about that now. So like, for example, let's say you have a record, and some people are only focused on making changes to some parts of the fields in that record. So like, let's say they're only focused on making changes to these 4 fields. So what you could do is you could build some hashes to compare the hashes in different ways. You can do, this is a play on the ghost of Christmas past, present, and future. So it's the hash of the past, the hash of the present, and the hash of the future. And this is a term that my friend Mark Scott here came up with. I just added the emojis. So the hash is, how many of you know that you could use the getContainer attribute to return a hash on non-container data? That's a function that you can pass in just text fields and get a hash back of the value of those 4 fields. Okay, so we'll look at the hashes in the example later. I just wanted to talk about it now. And then what you would do with those hashes is you would compare them in different ways and see like if the past is, anything has changed from the past to the present or to the future changes that I'm submitting. I want to talk about this concept of ModelViewController real quick. How many of you heard the term ModelViewController? Okay. How many of you have tried to implement it in FileMaker? Cool, awesome. So this is a little bit of, this may be a little bit of a twist, I'm not sure, but bear with me. So in our evolution or journey, we started off with globals and we put the values in popovers, etc. But we ended up evolving to this local file technique. And the local file is basically a file that has, in this case, the file on the right is just a file with schema for the event table. And it's got just those fields that we're concerned with where we want to create data in those fields or edit data in those fields. In that file, once we created it, we embed it inside the hosted file in a container. So far, are you with me? Yeah? Okay, and then what happens is when we open the hosted file, we'll export this file to a temp directory. It's got no data in it. And then we'll establish a variable file reference to this file. Now we have a file reference to the local file. And then in the graph, we instance an occurrence of this table on the graph. And then this layout in this card window is based on a table in this file. Okay? And so the model is this one's the model. That's where your data lives. That's the local storage of the data. This part here is the view, right? That's the card window that gets put on top of whatever layout that you're on. And that's where you have your layout that's based in the main file, and you can make any changes to it that you want. But the data that's in that card window comes from data in the local file. So you're never sending any traffic to the server. You're just interacting locally. So, and then the controller is the scripts that are attached to the card window to take action on whatever data that you need to do, like validate the data or do some processing on the data before it gets sent to the server. So that's our take on ModelViewController and local file editing, and I'll show some examples shortly. Okay, so let's see here. How are we doing for time? All right. So the first thing we're going to look at, let's see, should I do this one? Oh no, that's not the one I want. This one here? No. I think this one. Oh, I think that's fine. Yes. Okay. So, so this is, which one is this? This is global editing. All right. So this is the first approach that we took, and what this is basically we'll create some global fields in our table, and those global fields will be the fields that we use to create, let's say, a new event. So we'll create a new event. So we'll create a layout. And this layout will then have those global fields on it, just like we have here. And then this layout will become our card window. So when we say we want to create a new event, it installs the card window. Those are all globals, and I can just fill them out, and there's no network traffic going on right now. And then when I'm ready, so we have the add event on a different layout, but it's the same card window. And so I can fill all this data out, and at this point, all this data that I'm filling out, there is no network traffic going on. It's just local. It's just in memory, in globals. And then when we're done, we submit it, and what it does is it takes the data and packages it up as a JSON, set of data, and then scuttles it over to the server and says, here, here's this data. I want you to create a new event, and it unpacks it and creates the new event. And so now we have our new record. And so that's the global approach, using globals for that. So if you look at the script, let's see if we can maybe zoom in there a little bit. Stop it for 1 second. So in this case, we're just looking if the event. I mean, we could do all kinds of validation. Okay, you can still also validate based on the actual data in the event table. So you're basically just looking if, in this case, we're just looking if the event name is empty, and then we'll exit the script. And then other than that, we would then, we don't do self-calling PSOS. We have two scripts. We have like a controller script and the call script that we call that runs on server. So there's a clear separation for that. So when this is run, what will happen is it'll go to this branch here and run the event on server. So if we run that, stepping through it, I'm going to step into the other one down below. Okay. Here is it. This one here. So we're going to step into that script so you can see what we're doing on the server. So basically, we sent the parameter over JSON. Then when we unpack it, we get all these variables, and then basically, we go down here and we create the record in the event table, and then that's pretty much it. Pretty straightforward, not complicated at all. Let's see what else. Okay, so that's the global approach. So this is also an update, and the update, all it did was take the data from the record and put it in globals, and then show the card window, and then call another script that does the same thing, except this time you're not creating the record, you're finding the record and updating the record. And so that's using globals. If we look at creating the local file, let's look at what we talk about local file. So I need some more water. Hang on 1 second. Okay, so in this case, what we do is we'll create a brand new file, and this file, we have a naming convention. Maybe you might have, so if you do a lot of this, you might want to come up with a naming convention. EM for event management, and then local. And then what we do is we put in all those fields that we would need to either create the record or edit the record. The other cool thing about the local file is that because it's local, you're kind of like carte blanche. You could do any unstored calcs you want. You could do summary values. So you're not concerned about performance because it's never going over the network. It's all just local. So at this point, we're just doing some formatting on the fields and on layout. Let's just fast forward this a little bit. And then at some point, when we're happy with the file and we're ready to upload it, we just close it, and then we'll stick it in that file in a container. So now we're done with the file. We'll close it, go in the main hosted file. We'll create a container field, and then once we have that container field, we'll stick the local file inside the container. We were going to call this the Trojan horse method, but I guess we were kind of not so keen on that. So now we're going to stick the file inside the container, and from this point, we're pretty much ready now to have this file get deployed and as part of the opening of the file. So now next step would be to create a file reference when you open this file, and we'll look at that next. Let's see. Okay, here, we'll look at the script that's involved in exporting the file. So here, what we do is we have the file. Let's see, what do we do? The script here. Yeah, so let me pause here for 1 second. Okay, so we go to the layout or the table that has that field in it, and then usually it could be just a utility table that has one record in it, and then we'll set up a variable for the name of the file. We'll set up a variable for the local path, and for full access, we export it out to the desktop. For users that use the system, we'll put it in that temp directory. And then that way, as developers, we can quickly have access to it. And if we make any changes to the model, we can quickly replace our file in a hosted file with a new version of the model. And then what we basically do, this is on open. We set a variable for the file name. We set a variable for the path, and then we export the field contents. And then that's the script that runs when the user opens the file, and then the file is deployed. And and then what we do is this is showing the custom function. Basically, it's just if it's full access, we get desktop path. If it's not full access, we get the temporary path. Let's see here. Oh, there it is. Oh, I'm going backwards. So, and then you have file triggers. The file triggers that open when the file opens will piggyback off those file triggers. And if it's running on server, we'll just exit. But otherwise, when the user opens the file gets deployed. And let's see if we look. And this is on close as well. So we have a custom function that is basically, if is server, then it knows to exit that loop. And how many of you have used a pattern called single pass loop? You know that pattern? That's okay. So some of you, we use it almost extensively, always in every solution. And that's basically, we set up a loop here, and we can exit out of the loop with any condition like this, or at the end of the loop with a condition that says exit loop if true. And so we have one place to enter the script and one place to exit the script. And that's the pattern that we often do. Okay, so what else is in here? Do we do anything else? No, that's it. Okay, so let's look at the other example. This one is 3. Okay, 4. So then we create a layout. And we create a layout in the hosted file. And in the hosted file, we'll create a card layout. But we'll use the variable file reference to the local file and get a table from the local file into the graph of the main hosted file. And then once we have this table occurrence, we create a layout based on that table occurrence. So now we'll create a layout based on that table occurrence. And this layout, because it's based on that table occurrence, any fields that you put on that layout from that external table occurrence are not going to have any traffic going out. It's all going to be stored locally. So let's see if I can speed this up a little bit. Okay, so now we've copied and pasted like the design of the other layout. Let's speed this up a little bit more. And just tweaking some of the design stuff here. We're putting the fields on there. And now we have that ready. And then there's the local file. So here's the card window. So the layout or the file on the left is hosted, but its layout is based on a table occurrence that comes from the local file. So if we add some data there, that data is going to show up in the local file. So that record is going to show up on this file. So that had no network traffic at all. It's all local. And then, okay, so that's that. Let's look at one other thing. Here. Let's see. 5. Okay, so let's look at using the network monitor tool to measure performance. So again, so for measuring this, we would quit and clear the cache. So this is a little movie of using this tool. And so, but I already did that. So now I put myself in a state of what I want to measure. And I start the network monitor and I start entering data in this file. Now, if you were in a normal FileMaker file and entering data in here, and you accidentally clicked outside of a field, that would implicitly lock the record, which would mean that it would be sent to the server, and it would get locked, and all that traffic would go to the server, and then you would send the whole record over to the server. But in this case, if you were to accidentally do that, no traffic would be sent, the record would be committed, but it would be local. So in this case, we're filling all this out. Let's see here. We'll fill it all out. Then we create the record, and then we stop the monitor. When we stop the monitor, it gives us a measurement of how long it took. And so we create a log entry for what we did. So creating an event in the local file, save it, and then it shows us some numbers here. So like if we look at this, so if we were to use native FileMaker, which is the first record, we would be having 47 kilobytes of data coming down and 14 kilobytes of data going up. If you use the global method of creating an event, a record, using globals, and so you're storing the data in the globals, and then you're running a script to create the record on the server. We're talking in different measurement numbers here. Now we're talking about bytes. 740 bytes coming in and 937 bytes going out. If you do it with the local file, there's a little bit more overhead, but there's some advantages to the local file which we don't have with the hosted file. And so those are some measurements using the network monitor tool. Let's see what else we have here. So, so now one of the benefits of using the local file technique, which you don't have with the hosted file, is that in one window, I could start an edit, and now I have two windows, right? And I could start another edit, right? So now I have the local file has two records, and they don't crosstalk. If you use the global field method, then you have crosstalk. You can't do this. You can't allow a user to start an update on two records. And I've asked some of our clients, in some situations, the clients that do this, and they said, oh yeah, we often start editing something over here, and we do something else, and we haven't completed it over here, because they need to plan out different things, and they're starting the work, but they haven't completed it. So this is often a use case that actually you think might not be applicable, but is actually very applicable. So and with the local file, you have different individual records that you're targeting. So very, very useful. Okay, so those are my movies. And we could take a look at the files if you like, in more detail. And let's see here, where are we at for time? Okay, so go back in. So we saw the difference in performance. There's one I didn't do, which is the data API. The data API is like the Rolls-Royce method of using this technique. And the reason for that is, if you remember when I submitted my JSON parameters, I unpacked each one, I created a variable for each one, and then I was very methodical. I created a record, and then very, very step-oriented, and then you would see like set field, set field, set field, and then commit. With the data API, you have to be more skilled, and you have to prepare the data in the right data API format, and then with one call, you're basically updating or creating a record. Or you're creating a record with ancillary other related records. Or you're updating a record and updating all child records. It's one call. So like, if you're skilled enough at using the data API, and you can build the JSON payload that's required for the data API, then you could have a lot lighter code, and then it's one transaction, and then you also know whether the transaction as a whole was successful or not. So I didn't show it here, but I can show the file in just a minute, but there's the numbers on how much better the data API is. It's about comparable to what the local method was. So just to recap the journey, we did originally we had popovers and using globals. Then we developed this local file technique, and originally the local file had layouts and scripts in the local file, but then we discovered that all the layouts and the scripts could live in the main file. All we needed was a table in the local file, and that's all that's really needed. And as a matter of fact, I didn't show it in the demos, but the local file itself could be as minimal as this. So here's my local file with the same event management table in it, but it has in this file, it only has one layout. It's called event local. It's based on a table called local. The local table has no fields on it. The relationship graph has only one instance of that table occurrence called local. So it's got nothing in it, basically. It's got one layout. It's tied to the local table. That local table has no fields in it. So how does it get the event table? That's because we have the event table in here, and this is where the fields live. So it's a real, true model. In my opinion. It's very, very lightweight. And you can put auto enter account and password inside this file so that it automatically opens without full access, so the users can't get in there and do stuff with it. So because it's not hosted, you can use the auto enter password settings. So very, very cool. Let's see, what else do we have? All right. So we talked about the journey, local file editing, globals, single add or edit, and data can be validated before creation. The drawbacks is you can't do multiple edits. The local file editing approach can give you a single add or edit at a time, but data can be validated before creation, but supports multiple edits in different windows. Or I can start a new record in another window because it's in a card window, and I can start another one in another window. So they're all individual records in the local file. So very cool. A little bit verbose to put in place because you want to, unpack all the variables and then set all the fields and all that, which using the data API, you could be a lot more efficient. So using the data API, you can add or edit, but edit can also be multiple related records. So you can have a lot of flexibility in what you can do there. Data can be validated before, because you can run scripts on the data that is in the local file. So not to be confused, we could still use the local file as a technique to enter the data, but the mechanism by which we send the data is using the data API. So the local file is still useful in the case of the example of using the data API. Less verbose, but more complex. So it really depends on your skill level at working with the data API at that point. Just to recap, we talked about pessimistic versus optimistic, the differences between what FileMaker is natively and what you can do, and what we talked about there. But the difference is that I think you really have to be careful and you know what you're doing if you embark upon the path of being an optimistic record locking person. We talked about different techniques: commit footprint, local file editing. We introduced this concept of hashes, and I can show you that in an example file that we have. And I gave you the warnings, and I'll repeat the warnings. It's like, be careful using this approach because you really have to be understanding what you're doing when you embark upon this. Different approaches that we talked about: local, global, and data API. And then ModelViewController, we talked about that and how that is structured in terms of the local file. Clear separation and easy to implement. I think that if at all, and you were to embark upon this, I would probably suggest you take the route of the local file editing to do your optimistic record locking, and maybe not go down the path of using the data API right away, so you get a feel for it. But okay, so there's going to be some session updates. I'll have the example files on there, just some quick resources. Again, the network monitor tool is going to be available on the community. You should just search for it. Eventually it'll show up. Todd Geist has like a YouTube video about transactions. We've done a lot of blog posts. There's one blog post that talks about imports on server. So basically, in conclusion of this talk, if you do anything with data and you want to improve performance, you definitely want to look at things where you can run that on the server. That includes imports. So you could also run imports on server. And this blog post, it gives you some capabilities, native capabilities to run imports on server. And this requires FileMaker 18. Greg Lane has a talk right after this one, maximizing FileMaker performance along the same. Oh, that was yesterday. Oh, yeah, that's right. I was going to say that this was related to my past and present future thing. Okay, so Chris Irvine is doing a concurrent talk. So past, present, and future under the hood performance features of FileMaker Server 18. So that's, I think, is that one tomorrow? The under the hood one? FileMaker Server? That's today. Okay. Oh, you know what? Mike Beardy is doing a talk right after this. That's what it was. So you should definitely go see his talk. It's in line with all this, but he's doing all kinds of cool things kind of related to using other services and stuff. So definitely go see his talk. And then Chris is just across the hall there doing his talk. You should definitely watch his video later afterwards. We have a little bit of time for questions, and then I'll show just one more thing in the files, and then we'll take some questions. So here, let's see here. This is the local file. And if I go and do a new record, so this file has a record in here. Let's see. Oh, that's the event local. Where did it go? Oh. Not sure where that went. Let's see. Okay, I'll add it again. So I just want to show, oh yeah, the edit. So if I go to the edit and I change this record, so in here, when we update the record, we'll see that we'll see over here that we're doing some validation to make sure that the event name is not empty. We'll show a dialog if it is, and then we create the JSON for the event, and then this is where we generate those hashes that I was telling you about. So the hash is basically I generate a hash of what the data was before I started the edit. So that's a past. Then I generate a hash based on the data that I just modified, which we call the future, because that's what the data is going to become if we commit the record. And the present hash is what's on the server. So if those, if the hashes of the event past and the future hash, which means if I haven't made any changes, then just exit, right? And then we have another condition where if the present hash of the server is different than the hash of the past, that means someone else has edited those fields, not the record. Again, remember talking about record modification count. So those specific fields that you're interested in, if anyone modified those fields while you were going in to make the change, then you would warn the user. And in our case, usually the client's not so concerned about that, more concerned that we log the changes of who made changes when. So anyway, so that I just wanted to show you that. And then these two files, the local and the global editing file, I will post on the community so you can put them and host them on your server and look at them. So that's, let's see, let me just wrap up here. Officially end the session. So these are the resources. Oh yeah, some credits about the images I use, and then it will have updates. So any questions? Any questions? So thank you. Oh, you have a question? Yes.
Thank you. This local file technique is really intriguing, and it seems like there would be a lot of possibilities with using the local file. I was thinking that in some cases it might actually be desirable to keep the local file there. For example, if you have a big form that somebody's editing and FileMaker crashes in the middle.
Oh yeah.
You've just lost all that data, which maybe you might have committed, in a hosted environment, you might have committed at some point in there, right?
Right.
You would have saved half of it. But if you have, 30 fields you got to fill out, FileMaker crashes, it could be beneficial you could have saved that local file. Yeah. Reopened it. Have you thought about that or tried that at all?
That's a good point. And maybe, because what we do in the local file, we always clean up after ourselves. So it could be that when you open, you say, hey, I see some records still in there. Let me recover from that and say, what were you doing? And you could find the record that you were on and bring back the user and bring back the form in the state it was. So definitely possible that you could restore the fact that you came back after crash. Because I didn't show this, but when you bring up create a new record, it creates a new record in the local file. You fill out the data. When you submit, it sends it to the server, creates the record, and deletes the record in the local file. So you only have data in there while you're creating or editing any data. So in your case, if you were to crash, your record would still exist. When you reopen, it could do that checking for you. So that's very possible. One other thing I didn't say, which is important to mention, for this solution, what we do is our users don't have, from a security perspective, our users have no edit capability, create capability, delete capability in the privilege set. They only have view capability, and sometimes limited view capability based on certain conditions. So they can't even go to a layout, enter a field, and make a change. They have to go through this process. So that's a way to also ensure that they don't kind of accidentally behind the scenes impose a lock on a record that you don't have access to anyway. So go ahead.
Can you elaborate on the single loop pass and what it does, exactly how it works, and what the advantages are?
Yeah, so the single loop pass gives you a structure where you have one entry point and one exit point. So you basically start a loop,
Okay.
and then the loop always will exit because you have an exit loop true condition just before the end of the loop. So if you run the script, it will always go through the script and it will exit normally just as you would run a script that has nothing in it. But then inside that bounding loop, you put your code, right? And then inside the code, like you saw in our code, we had some condition that checks something, and then we exit that loop. So because of that, you have one exit point, and then after that, you could do some kind of a try-catch block underneath, and you could trap for any errors that were encountered in the execution of that loop. And so it's easy. It's good practice to have one entry and one exit point. And
Set an error variable inside the loop.
yeah,
Catch it outside.
exactly.
But essentially, the loop isn't, if I understand correctly, it's not actually.
It's not looping.
Okay.
As soon as it gets to the exit loop condition, the exit loop condition is true by that's always there, so that you don't get stuck in the loop. Okay, but it will exit there for sure. So you're not going in a loop out constantly. Yeah. Hey, Michael.
Hey, I just want to be clear about something. When the third piece, when you commit via the data API, you could do that whether local or globals. The call to the server, you could do it with either case, right?
You could do it local or global.
When you had the local file,
Yeah.
you can take your stuff and send it to the data API. If you were using globals, you could do the same thing.
Yeah, you could do the same thing with the globals as
Right.
well. But the difference is with globals, if you want to provide an interface for the user, you get stuck with this idea that if I open up this window and I start editing,
Yeah.
if I open up another
You
window,
only get one.
you only get
edit
one
at a time.
instance, where the local file gives you this flexibility to have like a local cache that FileMaker has its own cache we don't have access to. This is a way for you to create your kind of cache, if you like. So,
Okay.
yeah. Another question? Yes.
On the perform script on server variation, if you weren't going to take it as far as data API, your add event script had explicit set fields for each piece of data.
Yep.
Do you have any thoughts about making that bit of it more generic and sending field name and value pairs?
Yeah.
And running that in like a set field by name loop instead
Yeah.
of
You definitely could do that if you wanted to.
any advantage or disadvantage to one over the other?
The data API gives you a true transactional component where, let's say you had portals related data, like all that data would get committed at one time. So one push commits all the data in the parent record and all the child records. If you have multiple portals, that would all commit at one time. Whereas this other method, if you needed that, then you wouldn't have that. You would have to do some extra work to get it. And in the past, the technique was to loop through the portal and then make sure all the data is okay and then commit. That gives you the transactional aspect of that. But the data API is inherently transactional. So, yeah.
Thanks.
Okay. Last question?
How is this applicable to WebDirect, and how is this applicable to WebDirect, and have you done any test measurement?
Well,
and which of those methods apply?
Yeah, so the WebDirect method would only work with globals and popover because we don't have card window support until today, we heard, yeah. So maybe next year you would have that, but I don't know what the future of WebDirect is at this point. So popovers would work with globals, and you could use this technique, yes. What? Local file would not work on the WebDirect. You would have to just use the global technique where, yeah.
You wouldn't have an issue with somebody being able to pull up a new window and start editing in another window, though, if you're working on WebDirect, right? I mean,
well, if you open up a new window,
but the global issue with having like you've
Yeah.
got one window you're editing in, and you pull up another window and you're editing in, that's less of an issue with WebDirect.
would that create different session? Would that create a new session for that user? I don't know. Yeah,
second window would be a second session.
second session.
completely.
Yeah. So yeah, it would be fine. Okay. I think that would be the last question, or I can hang out from answering more questions.
Just back once to the loop structure that you're talking about, the one-out loop structure. I just want to be sure if I understood why you use that. Is it kind of like instead of doing a subscript where you pass off to a subscript which you can jump out of at any point, including at the end that you do it, or why bother with it?
Yeah, I think if you search online, you'll find other people have different opinions about it. But it's a good way to enforce that you have control at one point to control like anything that happens in the execution of your script. Otherwise, let's say you didn't have the single pass loop, and then you encounter some problem and you say exit script or halt script, and it's like, it could leave you could have a script that calls another script that calls another script, and now nothing is returned to that other script, or you're just left in a state of like, leave the user kind of hanging. Where this kind of enforces an approach where like this script will return something for sure, okay, because it exits at one point, and then you can trap what you're going to return based on the execution and the error capturing of what you're doing afterwards. So you can guarantee a return of something. So, but I would invite you to search online and ask other people's opinion as well. Okay, thanks everyone.